Welcome to The Explainer. You know, every single time you crack open a fresh coconut or even just take a sip of packaged coconut water, you're actually drinking a liquid that has undergone this hidden, absolutely miraculous metamorphosis. Today, we're going to explore exactly how coconut water forms inside the nut, how it physically and chemically matures inside, and why the coconut tree goes through all this trouble in the first place.
Okay, let's dive right in and address a really fascinating puzzle. Think about it for a second. If a coconut is basically a completely sealed, hard shell hanging dozens of feet in the air, how on earth does a massive amount of water actually get inside it? I mean, it doesn't just magically appear, right? And the coconut certainly isn't generating water out of thin air. Instead, the tree has to pull off a spectacular feat of biological engineering to move water from the earth all the way up into the canopy.
So, Section 1, the upward water highway, from the soil to the canopy. Let's trace this incredible journey starting deep within the soil, because it happens in three distinct, really cool steps. First, water flows into the roots via osmosis. It's just moving from the wet soil where water is abundant into the root cells where it's less concentrated. Next, it actually climbs the tree's internal plumbing, which are these tubes called xylem, through a process called capillary action. This is where water naturally clings to the narrow walls of the tubes. And finally, it's pulled powerfully upward by transpiration. As the tree literally breathes from tiny holes in its massive leaves called stomata, water evaporates, and that creates a vacuum pulling more water up from below. But here's the thing, this transport system doesn't just stop at the leaves. The xylem actually bifurcates, or branches off, delivering this water straight into the developing nut. By the time it reaches the fruit, it fills a hollow cavity inside. But, as we're about to see, what ends up in that cavity is definitely no longer just ordinary groundwater. That brings us to Section 2, defining the liquid endosperm, and honestly, the totally bizarre biology behind it. So what is this liquid? The absolutely crucial point here is that this isn't just groundwater anymore. Scientifically, it's known as liquid endosperm. As the coconut develops, the plant undergoes a process called karyokinesis, which is just a fancy way of saying the nucleus divides. But strangely, it completely skips cytokinesis, which is the formation of cell walls. So because there are no rigid cell walls being built, you get these free-floating nuclei and a liquid bath. It's a highly specialized, free nuclear liquid tissue that is perfectly designed to nourish the seed. And as this water travels up the tree, the plant is enriching it with a very specific blend of nutrients. It packs it with minerals like potassium, magnesium, and calcium, alongside vitamin C, B vitamins, fruit acids like malic acid, and essential amino acids like alanine and valine. And because it's sealed so tightly inside the young nut, it is completely germ-free. Amazingly, this whole mixture creates an isotonic solution, which means it has the exact same osmotic concentration as human blood. No way, right? It's literally nature's perfect sports drink. All right, Section 3, the maturation timeline, tracking the 12-month life cycle. Let's look chronologically at how coconut water matures inside the fruit over a full year. In the first 3 months, the internal cavity is just forming. By months 5 to 6, the liquid is growing rapidly. But it's right at that 7 to 9 month mark that the coconut hits its absolute peak sweetness and maximum liquid volume. This is the sweet spot, literally, and it's what is commercially classified as young coconut water. After a year, from 12 to 15 months, the coconut enters its final maturation phase, and the liquid inside severely depletes. Now, to put that into perspective, the sheer volume of this liquid early on is just astonishing. Get this, a young Malayan-tall coconut at just 5 to 6 months old can hold up to 684 milliliters of water. That is well over half a liter of nutrient-dense liquid endosperm hiding in a single piece of fruit. But if you wait until that coconut is over 12 months old, that volume drops by more than half. Which leads us to Section 4, chemical changes and the sugar shift. To really understand how the water transforms, we have to look at the molecular data. Young coconuts at 5 to 6 months are just packed with simple sugars. They've got about 35.4 milligrams per milliliter of glucose and 39 milligrams of fructose. Sucrose? Barely there, just 0.85 milligrams. But as the coconut ages past 12 months, the glucose and fructose levels absolutely plummet, while the sucrose skyrockets to 14.4 milligrams. By measuring this exact sucrose to glucose ratio, scientists can actually pinpoint the exact age of a coconut. It's like a built-in biological clock. But the sugars aren't the only things changing. Alongside this massive shifting sugar profile, the acidity of the water drops. The pH level actually rises, making it more alkaline and sweeter to the taste. At the exact same time, key active enzymes like peroxidase and polyphenol oxidase, which, by the way, are the things that cause the water to turn pink or brown when exposed to oxygen, they steadily decrease as the coconut matures. So the entire chemical profile of the water is being completely re-engineered over the span of just a few months. Let's move to section 5, from water to flesh, the solidification process. So here's the big question. If a young coconut has nearly 700 milliliters of water, and a mature one has less than half of that, where exactly does it all go? Well, the answer is both super simple and completely astonishing. It quite literally becomes the coconut meat. As the coconut passes the 8-month mark, a portion of that liquid endosperm begins to deposit onto the inner surface of the shell as this thin, creamy tissue. Over time, the liquid endosperm sacrifices its volume to build this solid white kernel, hardening as the moisture levels decrease. When you look at a direct comparison, it is a breathtaking physical metamorphosis taking place inside that shell. We start with a young coconut, which is essentially a giant, sugary water balloon filled with liquid endosperm, glucose, and fructose. But fast forward a few months, and it transforms into a mature coconut, very low in water, packed with dense, hard, solid endosperm, and boasting a massive oil content of up to 43%. As that solid endosperm rapidly grows, it is hoarding vital lipids. It's essentially trading the water's simple carbohydrates for a sustained, incredibly rich energy source. Coconut kernel is made up of 90% saturated fatty acids, primarily medium chain triglycerides or MCTs. And a massive chunk of this is a 12-carbon fatty acid called lauric acid. This ridiculously dense fat reserve is entirely necessary to provide the massive amounts of energy the coconut is going to need to eventually germinate and grow roots. Finally, section 6, a natural survival package engineered for the ocean. Let's pull back for a second and look at the evolutionary reason behind this entire incredible maturation process. The science desk over at the Times of India summed it up beautifully. They wrote, "The coconut is a full survival package for future coconut trees, shaped by evolution to spread across oceans." And they hit the nail on the head. Every single stage we just looked at, the thick husk to survive a massive fall, the hard shell to protect the seed, and the nutrient-dense water perfectly transitioning into high-energy fat, it is all flawlessly engineered. It's designed so the coconut can fall from a tree, float across the harsh, salty ocean for months, wash up on some distant, barren, sandy shore, and have all the internal water and energy it needs to kickstart a brand new life. It truly is a marvel of the natural world. I really hope this explainer leaves you marveling at the incredible science and biology hiding inside your next sip of coconut water. Seriously, the next time you see one, ask yourself, if this perfect liquid is designed to sustain a seed across an entire ocean, what other extraordinary natural miracles are just hiding in plain sight, waiting to be understood? Thank you so much for learning with me today, and as always, keep your curiosity alive.